This is our last lesson for week 12. We're going to introduce something called complex numbers. But first let's consider the equation x equals 2. When we solve x squared equals 2, how many solutions do you get? Well, we need to think back that, okay, here's our x, our term that's squared on one side. This is a completely positive number, so we would expect to have 2 solutions, right? Because it's a positive number. Remember, positive number equals 2 solutions. And let's prove that. X squared equals 2. I'm going to take the square root of both sides. You get x equals plus or minus the square root of 2. Okay? And so how many x-intercepts does that have? Well, it's going to have 2. Positive radical 2 and negative radical 2. And what is radical 2? Let's see. Radical 2 equals 1.414. So that means I'm going to have positive 1.414 and negative 1.414. And when we go over to the graph, positive 1.4 is almost halfway, right? Estimating. And negative 1.4 is right here. So it's going to touch the graph at 2 places on the x-axis, or have 2 solutions, 2 roots, 2 zeros. How many x-intercepts does the equation have? It has 2 x-intercepts. Okay, 1.414 and negative 1.414. Okay, let's solve the equation. And so write your solutions in both exact form and decimal approximation. Well, I already did that. So we would have our exact form as 2, or 1.414, or negative radical 2, or negative 1.414. Okay. So mathematicians throughout history have resisted the idea that some equations may not be solvable. Still, it makes sense that x squared plus 1 cannot be solved because the graph of x squared plus 1 has no x-intercepts. So let's see what happens. X squared plus 1 equals 0. When we subtract 1, we get x squared equals negative 1. And look what happens when we go take the square root of both sides on this problem. Remember, we've been talking about, if there's a negative there, that means there's no real solutions. The other way is that there's no zeros or no x-intercepts. Okay, so no x-intercepts. Well, okay, what happens when you try to solve it? You get stuck, okay? You cannot find an answer for the square root of negative 1, right? That's what we get stuck at. We can't find an answer to the square root of negative 1. In the 1500s, an Italian mathematician named Raphael Bombelli invented the imaginary number, the square root of negative 1. So some guy said, okay, we're going to have to solve this situation. We can't just not be able to find an answer here. So he says that he made up a number, the square root of negative 1 is now called I, because I is defined as the square root of negative 1, and it follows that I squared is negative 1. So watch. If I equals the square root of negative 1, then if I square both sides, I squared equals the square root of negative 1 squared. And how many times have we talked about that if you have a square root and a square, these guys cancel each other out, and so you're left with I squared equals negative 1. So this is a very important thing. After this invention, it became possible to solve things like this. We ended up, remember, with negative 1. Well, that equals positive and negative I, right? Because the square root gives you 2 answers. Because of this, we can solve negative 16 as negative 16. I change I, or negative 1, we change it to I squared, and that becomes 4I. Well, positive or negative 4I. We're going to focus on the positive. So using the definition, let's solve each of these. So we're going to take the square root of negative 4. That's like taking the square root of negative 1 times 4, and we know that the square root of negative 1 is I, and the square root of 4 is 2, so that's going to be 2I. Let's multiply this. 2i times 3i 2 times 3 is 6. I times I is I squared. Here we need to remember that I squared is equal to negative 1. So this is really 6 times negative 1, or negative 6. Let's go right here. Negative 5 times, this is to the power of 2. So I have to take all of this, 2i times 2i, and becomes 4i squared. I'm going to multiply negative 5 times negative 4 and get negative 20. And then I squared, remember I squared is negative 1. Negative 1. So negative 20 times negative 1 is negative 20. And so when we get here, this is 5i. How do I know that so quickly? Because I know that the square root of 25 is 5, and that the square root of negative 1, because I can write that as the square root of negative 1 times the square root of negative 25. I could write it this way. Okay, square root of 25 is 5, square root of negative 1 is I, so 5i. There we go. Look at the next page. We want to graph this using Desmos. So I'm going to come over here to Desmos and I'm going to type that up. So let's see, I'm going to go down to here, go into Desmos, and we're going to type y equals, instead of f of x, I'm going to type y equals x squared minus 4x plus 5. Okay, so see how that does not cross the x-axis, and that's our first question on our paper. Does the graph cross the x-axis? Please write no for number 1a. You can see me down in the little corner, but you probably can't see anything. Does the equation x squared minus 4x have any real solutions? Well, real solutions means that it's going to cross the x-axis. So again, we're going to put no. Okay, I'm going to come back to my screen here. So far I've just put no and no. Now we're going to use the quadratic formula to solve this one. So the quadratic formula, I need to know what my a is. A is 1, b is negative 4, c equals 5. Quadratic formula, let's see. Negative b plus or minus the square root of b squared minus 4ac all over 2a. That equals x. So let's plug in negative b, which is negative 4, plus or minus the square root of negative 4 squared minus 4 times a is 1, c is 5, all over 2 times 1, which is a. And we're going to keep going. A negative and a negative, it's positive 4, plus or minus the square root of negative 4 squared is 16, minus 20, all over 2. Well, 16 minus 20 is negative 4, so we're going to get 4 plus or minus the square root of negative 4 all over 2. Keep going. So this is 4 plus or minus. Now I can figure out what the square root of 4 is. Before I always said there's no real solutions, but now I can say 2i all over 2, and I can actually reduce the 4 and the 2 is 2 plus or minus I. That is going to be the final answer on this one. Okay. Use our new understanding of imaginary numbers to rewrite your solution in part B using I and not with the square root of a negative number. Okay, so I basically did this in part C. Okay, that's already done. So we simplified it as much as possible and we got 2 plus or minus I. So we didn't want to leave it as negative 4. We changed negative 4 plus or minus the square root of negative 4 all over 2. We changed that to 4 plus or minus 2i all over 2, and then changed it to that. So the big key thing here is we wanted to change negative square root of 4 to 2i. All right? Kind of working ahead of myself because it's math. It's so much fun. A real number plus or minus the multiple of a plus bi, like the solution, is called a complex number. So 2 plus or minus I is a complex number. Check one of your solutions for part B by substituting it into the equation for x for simplifying the result. All right, so what they're saying is we're going to take, let's say 2 plus I. 2 plus I equals our x. And if our equation was x squared, minus 4x plus 5 equals 0. Let's go ahead and substitute this in. We're going to get 2 plus I squared minus 4 times 2 plus I plus 5. So let's check one of my solutions. I'm doing the positive one. So what is 2 plus I squared? Okay, I'm going to come over here. I'm going to go 2 plus I, 2 plus I, and we're going to get 4, 2I, 2I, I squared. So we're going to get 4 plus, add these two together right here, 4I plus I squared minus, okay, that's simplifying this is where I got this right here. Now I'm going to distribute this negative 4, minus 8 minus 4I plus 5. So let's see, 4I and negative 4I are going to cancel. 4 plus 8, or plus negative 8 is negative 4 plus I squared plus 5. I squared, remember, is negative 1. Negative 4 plus negative 1 is negative 5. Negative 5 plus 5 equals 0. Okay? So we have x is equal to 0. Describe in words the relationship between the graphs of the parabola and the kinds of roots in their equations have. Okay, so again, we're reviewing this. So if this is talking about, I can have a parabola that touches twice, a parabola that touches once, and a parabola that touches 0 times. Okay, so this is going to be 2 real roots. It touches one real root, and then this one is no real roots, or it's imaginary roots. Okay, so imaginary roots. Okay, can you see that?